Okay, so we have these 4 rivers and different spots along each river, and we're going to be looking at the amount of iron that were in a sample, one at each of the 3 locations for each of these 4 rivers. So we have 12 different data points here. So we're going to go to ANOVA, and note that it's not a repeated measures ANOVA. We're not repeating the same thing over and over again, even though we're testing the river in different locations. That's a separate beast here. Okay, so our dependent variable is level of iron, and we might eventually go to log of the iron, but for now we're just starting off with the iron. And then the 2 fixed factors are river and site. And when we look at our output, we get a residual degrees of freedom. What do I do? So because we have just one data point in each of our 12 cells, one thing we have to do is go to this model and take out this interaction term. We'll talk more about interaction terms in the next chapter. But this does allow us then to run the basic model there. So just to clarify, remember residual is the error. So this is the amount of variance that we're having that's unexplained yet, not explained at least by these 2 factors here. And we can look also at the mean squares here. Degrees of freedom is 3 because 4 rivers minus 1 gives us 3. Sites, there's 3 sites, down, middle, and up for each river. So 3 minus 1 gives us 2. 12 data points total, and we need this total to equal n minus 1 or 11. So that's how we get our 6 from residual there also. Get the average amount of how much that squared error is in our f terms and p-values here. But again, we create this model here, but there may be some issues with it. So here's where we want to go check the assumptions on the next couple parts. Now the normal probability of the residuals, this is quite easy. If we go to assumption check, QQ plot of the residuals, this is where we're looking for these residuals to pretty much line up on the straight line. And this looks great. I mean, we have a good, we're meeting this assumption fine. So the next one though, when we're supposed to get the residuals compared to the fitted values, you can spend some time clicking around here. Now we could run a homogeneity test. This isn't really going to tell us much in this situation. We really need those plots with the fitted values, so the predicted values on the x-axis, and then the residuals, their residuals on the y. And this is one of the most useful plots we can have. Tell that to JASP. They do not give you that option. I could not find this, whether I played around in all of these places and looked in this guidebook. So all is not lost. I will continue in the next video.